Given the finite sequence, S is equal to A1, A2, dot, 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 all the way till AN of n real numbers. AS be the sequence, A1 plus A2 over 2, A2 plus A3 over 2, dot, 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 AN minus 1 plus AN over 2 of n minus 1 real numbers. Define A1S equal to AS, and for each integer m with m between 2 and n minus 1, define AMS equal to AM minus 1s. Suppose x is greater than 0, and let s equal 1x, x squared all the way till x 100. If A100s is equal to 1 over 2 to the power of 50, then what is x? All right, first let's try to understand this question. What's going on? What's happening? All right, well, first and foremost, they give you this set. So they tell you that s is 1x, x squared, x3, and so on, right? All the way up till x to the 100. And then they tell you that A100s is equal to 1 over 2 to the power of 50. Now that is meaningless to us at this point in the question. So we won't worry about that. But what we will concentrate on is this right here. Okay? So I'm going to start with A1. A1s. And then I'll do A2 and then A3 and A4. And I think hopefully by then I should be able to get some sort of a pattern. Okay. A1s is just equal to AS. They tell you that. And AS is this equation or system or sequence or whatever you want to call it. All right, so here we go. How do we get AS? Okay, don't be intimidated. Don't give up and just go to the next question. Work with this. I encourage you. So, how do you get it? It's the first term plus the second term divided by 2. So, the first term plus the second term divided by 2. So, 1 plus x over 2. Okay. Next, we get to A2 plus A3 divided by 2. So, the second term plus the third term divided by 2 would be x plus x squared over 2. All right? And so on and so forth. So I'll just do a few of them. X squared plus x3 over 2, x3 plus x4 over 2, and it kind of goes on from there. All right? You get the point. All the way until x to the 99 plus x to the 100 all over 2. Okay. And what I'm going to do over here is I'm just going to write the number of terms. I just want to put that in there. And for the first one, right, how many terms do we have if we had to count them all? Well, we've got 100. 100 terms. So I'll just put that in there, 100. Squeeze it in there right there. That will make a little bit more sense later as to why I did that. All right, let's turn our attention to A2s. Okay, so again, attempt it. Don't get discouraged. Don't get intimidated. Same formula right up here. A1 plus A2. So this time, this is my first term. This is my second term. So 1 plus x over 2 plus x over 2 all over 2. Okay, that's the first one. Second one, the same way. X plus x squared over 2 plus x squared plus x to the power of 3 over 2 all over 2. Correct? Following? No problem so far? All right, here we go. Keep going here. I'll just do, what should I do? One more? I think one more should be sufficient. So the next one, let's see here. It's x squared plus x to the 3 all over 2 plus x to the power of 3 plus x to the power of 4 all over 2. And so on dot, dot, dot. Okay, keeps on going like that. And this has 99 terms. All right, remember I wanted to put in the terms. All right, now let's go to A3. I think by now you're getting a little bit of the hang of it. So this now, we have to add these. But before I put in A3, I'd like to simplify this a little bit because this is kind of messy. This is going to be 1 plus 2x plus x squared. And that's all over 2, which is all over 2, so it's actually all over 2 squared. And then this is x plus 2x squared plus x to the power 3, all over 2 squared. And this is x squared plus 2x to the power 3 plus x to the power 4. Oh, forgot the 2 there. So that's all over 2 squared, and this kind of keeps on going, dot, dot, dot. All right, now I'm ready for A3. So here we go in a very similar way. The first one plus the second one. So that's going to be 1. I'll just simplify it immediately. 3x plus 3x squared plus x to the power of 3 all over 2 squared all over 2. So it's 2 to the power of 3. Right? I just saved a step there. And the second one, x plus 3x squared plus 3x cubed plus x to the power of 4 all over 2 squared, which would be 2 to the power of 3, dot, dot, dot. And this has 98 terms. So put that 98 in there, number of terms. And I'll just do one more, and then we'll go back and look at this and see if there's any kind of a pattern. A4S. All right, A4S, obviously we're going to add these two, so it'll be 1 plus, let's see here, 4x plus 6x squared plus 4x to the power of 3 plus x to the power of 4 all over 2, all over 2 to the power of 3, which will be 2 to the power of 4. And then dot, dot, dot. And this has 97 terms. Okay, now let's go back and look at this from the perspective of pattern finding. So A1S, this is my first term. Okay, doesn't really help me in any way. A2S, this is my first term. All right, that looks very familiar. It looks like x plus 1 all squared, well, obviously over 2 to the power of 2. Okay, this was x plus 1 here over 2. This is x plus 1 squared over 2 squared. All right, let's go to the next one. This is the first term. This is x plus 1 to the power of 3, all over 2 to the power of 3. And then if we look at a to the 4, and look at that first term, that is x plus 1 to the power of 4, 2 to the power of 4. Okay, I got the pattern. The pattern, basically, is that ANS will be x plus 1. The first term will be x plus 1 to the n all over 2 to the n. And these terms, the number of terms that I drew here, that's important. Very important, actually. Because here it was 100, 99, 98, 97. But what about n? If it's an, how many terms? It's 101 minus n. Okay, it's not a genius to figure that out. I mean, I just looked at the pattern. Right? It fits. So, we are interested in A, if you remember, 100s. That is what they were asking us. Okay, well that's going to be x plus 1 to the 100 over 2 to the 100. Okay, and what's interesting about A100s, how many terms will there be using this formula? 101 minus n, which is just one term. This will only have one term. And that one term, if you were to make a list, it will be this guy right here. That's the only term. X plus 1 over 100 over 2 to the power of 100. And they tell you in the question right here that A100s is equal to 1 over 2 to the power of 50. So this is equal to 1 over 2 to the power of 50. All right, I can figure this out now. So here we go. X plus 1 to the power of 100 over 2 to the power of 100 is equal to 1 over 2 to the power of 50. Correct? X plus 1 over 100. I'll put this guy up here. So that'll be 2 to the power of 100 over 2 to the power of 50. So x plus 1 over to the power of 100 is equal to 2 to the power of 50, right? Because it's 100 minus 50. And then I'll put this in terms of squared all to the 50, making the exponents the same. That's perfectly allowable. And since the exponents are the same, I can just concentrate on what's the base. And the bases are just x plus 1 squared on that side and 2 on that side. And then this becomes just x plus 1 is equal to the square root of 2, right? Take the square root of both sides. And finally, x is equal to root 2 minus 1. There you go. Pretty cool, right? It's a good question. So x is root 2 minus 1, and therefore number 23 would be choice B.